A pleasant day to our distinguished panel of reactors and participants to the 6th International Conference on Social Sciences and Humanities 2021. I am Vanessa Asayas, the faculty member of the Davao Oriental State University, and it is my pleasure to present this study titled Vertical Distribution of Soil Organic Carbon Content in an Age Sequence of Rice Paddies in Davao Oriental, Philippines. Today, I will briefly present the background of the study, the methods used, results and discussion, and the conclusion and recommendations. Soil organic carbon, or SOC, is considered a win-win solution that addresses both food security and global warming. SOC is a determinant of soil health. It enhances soil quality and increases productivity. According to recent studies, increasing SOC also offsets anthropogenic carbon emissions. Hence, it is a viable mitigation strategy against global warming and climate change. With this, the study investigated the soil organic carbon content of rice paddies, one of the major agricultural land use systems in the Philippines. Specifically, the study measured the SOC content in different soil horizons of rice paddies with varying cultivation age, with the ultimate goal of providing site-specific data on soil carbon that can be used to attain a more reliable estimation of the country's carbon stock. The study was conducted in selected rice paddies in the municipality of Banay-Banay, Davao Oriental. The study sites were categorized based on the years of cultivation. Site 1 has been cultivated for less than 10 years, Site 2 for more than 20 years, and Site 3 for more than 50 years. Soil samples were collected using the coring method at the end of the harvesting season when the soil bulk density of the rice fields reverted to the pre-tillage conditions. Before the laboratory analysis, visible plant residues were removed from the soil samples, then air-dried, fragmented, and sieved through a 2 mm mesh. The organic carbon was determined using loss and ignition. The soil organic matter, or SOM, was computed using the equation shown in the screen. The Van Bemmelen factor that is equal to 1.724 was then used to convert SOM to SOC, based on the assumption that organic matter contains 58% organic carbon, hence this equation. Table 1 provides the descriptive statistics of the vertical distribution of soil organic carbon concentration along soil strata and its difference across sampling sites. Results indicate a decrease in soil organic carbon content with increasing depth. On average, the highest SOC content was found in the soil surface. The second layer recorded an average SOC content of 0.048 gram of carbon per gram of soil, whereas the bottom layer had the lowest amount of 0.047 gram of carbon per gram of soil. The highest mean SOC content was recorded in Site 3. Site 1 recorded the second highest mean SOC content of 0.049 gram of carbon per gram of soil, while Site 2 obtained the lowest mean of 0.046 gram of carbon per gram of soil. Standard deviation within each group indicated a small amount of variation in the data. The two-way ANOVA demonstrated that there was no statistically significant interaction between the effects of soil depth and cultivation age on SOC content. The relative impact of the soil depth to SOC content is also slightly greater than the years of cultivation, based on the partial eta squared of 0.168 and 0.155 respectively. The adjusted R-squared reported that only 25.3% of the variance in SOC content can be attributed to the interaction effect of cultivation age and soil depth, while the main effects of soil depth and cultivation age were both statistically significant. The results of this study were in agreement with previous studies that determined higher SOC content in the topsoils compared to the deeper soil horizons. The plausible reasons for this are the following. According to Wells et al. Of 2012, SOC is found primarily between the soil surface down to 30 centimeters below because this horizon is the most biologically active. Aside from above-ground biomass, several authors also believed that higher SOC in the upper soil horizon might also be brought about by the accumulation of root biomass. Other authors even postulated that roots actually protect SOC. Other researchers also indicated that land use management practices predominantly drive SOC depth depletion. For instance, tillage was found to profoundly affect the vertical distribution of SOC. Tillage is believed to affect the distribution of carbon in the soil and the rate of SOC decomposition. However, other studies found higher SOC in the subsoils than in the topsoils. Wismayer et al. In 2012 suggested that the subsoils of most ecosystems contain 50% more SOC than that of the topsoils. Bavie et al. Of 2016 also stated that soils beyond the 25 to 30 centimeters layer store more carbon. The results of this study revealed a decline in carbon with increasing depth. This may indicate that the subsoils in the study sites were not yet saturated and still have a great capacity to store additional carbon. This study found lesser SOC content in more recently cultivated paddies and a significantly higher SOC in the 50-year-old rice paddies. This pattern agrees to the assumption that SOC content in the agricultural lands stabilizes through the years until it reaches saturation level wherein the soil can no longer sequester additional carbon. Farming practices could have also contributed to the variation of SOC content in our sampling sites. According to the interviewed farmers, rice production in the sampling sites is uniformly characterized by continuous flooding and puddling. Although tillage alone could not account for the difference in the SOC content of the sampling sites, it is important to note that previous studies observed higher SOC content in soils under conservation tillage than in soils under conventional tillage. Reducing tillage intensity was even recognized to be a viable option to increase SOC. Farmers' post-harvest practices also include leaving the plant residues to decompose back into the soil, since there is a municipal ordinance that prohibits the farmers to burn rice straws. This post-harvest practice, together with a longer fallow period, could have allowed optimum rice straw degradation and soil carbon rehabilitation in the field, resulting in higher SOC content. The difference in the SOC content can also be attributed to the extent of fertilizer use, since soil fertility enhancements can increase SOC. Interestingly, the application of a nitrogen fertilizer enriched SOC according to several authors. On a negative note, intensive application of nitrogen fertilizer may enhance nitrous oxide emissions, and the production of synthetic nitrogen fertilizers also uses fossil fuel, which further releases carbon into the atmosphere. Hence, when thinking about using rice paddies as a carbon sink, we also have to consider this aspect. In conclusion, SOC content declined in the first 20 years of rice cultivation and stabilized after 50 years. This may indicate that the soils are approaching saturation level, wherein soil carbon can no longer increase regardless of carbon input. Land use management practices are also factors that might have affected SOC concentration in the study sites. Using environmentally friendly farming practices can help optimize SOC storage and sequestration for both food productivity and global warming mitigation. Rice paddies may have immense potential in storing carbon depending on management practices. However, adoption of the recommended management practices needs to be studied thoroughly in order to ensure its effectiveness in the target sites without compromising the people's livelihood. There is also a need to further explore carbon dynamics and fluxes in rice systems, including the magnitude of carbon storage, as well as the emissions of other greenhouse gases. Rapid and cost-effective national protocol and standards in measuring SOC stock must also be established. And that would be all for the study titled Vertical Distribution of Soil Organic Carbon Content in an Age Sequence of Rice Paddies in Davao Oriental, Philippines. Thank you very much.